Assalamualaikum warahmatullahi wabarakatuh. Today our group will present the role of organic chemistry in the production of ink and pigment for art and printing. Before we start our presentation, we would like to introduce ourselves. My name is Abdullah bin Omar Jamat.
Hi, my name is Muhammad Alif Alauddin bin Hassan.
My name is Saiful Amir.
Hi, my name is Nur Sabrina and you can call me Sab.
My name is Nur Auni Hazia binti Muhammad Azizul and you can call me Auni.
Topics covered in this presentation is reaction, specific application, molecules and their characteristic, and lastly is production. Producing ink and pigment for art and printing involves a meticulous process that blends chemistry with creativity. From vibrant hues to precise formulations, these materials are crafted to meet the exacting standards of artists, designers, and printers worldwide. This integrated production journey encompasses sourcing raw materials, refining pigment, adjusting viscosity, and ensuring color accuracy, all to achieve the perfect balance of quality and performance on paper, canvas, or digital media.
Now, we move to reaction. The chemical reactions involved in making inks and pigments are varied and complex, depending on the specific type of ink or pigment being produced. Here are some examples of key reactions. First, we have azo-coupling reaction, azo dyes. Azo dyes are a major class of synthetic dyes used in inks. The basic reaction involves the coupling of a dianosmium salt with a phenol or an aromatic amine. The reaction is like below. Next, we have indigo synthesis. Indigo is a natural dye. Can also be synthesized through a chemical process involving the fusion of phenyl glycine and sodium hydroxide, followed by oxidation. The reaction is below. Each reaction is tailored to produce specific color properties, stability, and suitability for different applications.
So, for application of ink, ink can be found everywhere from textbooks, some printed pictures, to our favorite pen. And because of how versatile and wide range usage it is, a lot of things in this modern day need the application of ink. There are a lot of applications for printing, one of them being for printing technology. Printing technology has its own different types, one of them being offset printing. It is a method of a mass production printing in which the image on metal plates are transferred to rubber blankets or roller and then to print media. Other than that, there is also flexographic printing. Flexographic printing utilizes a flexographic relief plate. It is basically a modern version of letterpressing. There is also grave printing, which basically a printing with a high viscosity for precise product transfer in fine detail. An example of ink is for writing. For the ink to be applied in writing, it requires a tool for the ink to be transferred on paper. So, of course, the tool being pens, and pen has a lot of types. One of them being the basic ballpoint pen, with the low viscosity for the ball to have a smooth movement and controlled flow. There is also fountain pen. Fountain pen use a subtle viscosity and a flow for capillary actions and control flow. Then there's gel pen with a high viscosity and thiotropic properties for smooth writings and vibrant colors. Markers, on the other hand, is a quick drying, good adhesion and resistance to smudging or bleeding. Ink can also be made into special type of ink such as invisible ink, UV visible, or magnetic ink is a type of security type of ink. Furthermore, there is also a conductive types that use silver, carbon, and graphene-based products for printed electronic. Last but not least, there's a ceramic types which is a high temperature ink for it is stable for product. It is a stable ink for printing on ceramic or glass.
Next, I will explain to you guys about the molecules and their characteristic in ink and pigments. So firstly, the molecular formula of ink is 614H26 N2O4 and S. This formula is used to identify the specific ingredients of inks and is the chemical composition of the ink, which is the basic for its color. It can be made up of several elements such as sulfur, oxygen, copper, and nitrogen. Ink is made up of different chemical compounds. A few of the compounds can be categorized as organic and inorganic. I will talk about the primary active molecule of ink and pigments. Both pigments and dyes come in a wide range of chemical composition and colors. Next, we have solvents. Solvents are active molecules that dissolve the pigments or dyes and help maintaining the ink viscosity or thickness. Next, we will have resins or binders. In some types of inks, especially those used in a printing processes like offset printing or flexography, resins or binder are active molecules that help the ink adhere to the printing substrate. These molecules form a film when the solvent evaporates, binding the pigment or dye particles to the surface. And here we have additive. Additives are active molecules added to inks to modify their properties. And lastly, we have metallic compounds. In specialty inks like metallic or glitter inks, active molecules can include metallic compounds such as aluminium, copper, or bronze particles, which impart a metallic or shimmering effect to the ink.
So for the first step in the production of ink and pigment, it involves the creation of organic pigments. So these pigments derived from natural sources such as insects, plants, and animals have been developed over centuries. The production of ink involves several steps. Initially, the pigment is manufactured using pigment from organic synthesis. This pigment is then suspended in a liquid and encapsulated in synthetic resins. Ink additives are often thickness or rheology modifiers, control the ink's viscosity and flow properties, ensuring a smooth application. Finally, for the sustainability is becoming increasingly important in the pigment industry. Unlike non-renewable raw material of synthetic dyes, the natural dyes are mostly renewable and sustainable. The ability to obtain the dye from renewable sources make the natural dyes an attractive dye class for a more sustainable world.